Hello everyone, welcome to Math World. This video is to discuss trigonometry paper 3 for the harmonic form. Okay, so basically there are two forms. The first form is we need to express a sine theta plus minus b cos theta in terms of sine. But then it's just one term, therefore it is in the general form of r sine theta plus minus alpha. Okay, so the second form is you can express a cos theta plus minus b sine theta in terms of cos, r cos theta minus plus alpha. Okay, so how do we decide whether it's sine or cos? So you have to check here. If this is sine, that means first term must be sine. If this is cos, then the first term must be cos. And for the sine, it will follow the plus or minus sign here. So which means if it is sine of theta plus alpha, then it must be a plus. Okay, for the left hand side. But then for the cos, if it is minus, it's like r cos theta minus alpha, then here is going to be the addition. Okay, so now these are the two general forms. But now the problem is, okay, you are given the left hand side. How do we get right hand side? So now from here, theta is the unknown or is the parameter, or I would say that it is the angle. Then we need to know what are the values for r and theta on the right side. Okay, so basically once you are following this form, okay, that means if here is cos, so first term is cos, that means the coefficient for cos theta is going to be a. Then now I will know that my r is basically square root of a squared plus b squared. Okay, and my alpha is going to be arctangent b over a. So we will just calculate the r and alpha using these two formulas. Okay, so that's all for the notes of the harmonic form. So let's go to the example. So first question, express 3 sine theta minus 5 cos theta in the form of r sine theta minus alpha, where r is greater than 0 and the alpha is between 0 and half pi. Then A, hence means use the previous answer. Write down the greatest and least value of this expression and state the corresponding smallest positive values of theta. Then B, solve the equation where the theta is defined from minus pi to pi. Okay, so first of all, I will express in the harmonic form first. So now you can just check. Okay, when the right side is sine, so the first one must be sine. That means my A is positive 3. And here, if it is sine, you have to follow the plus or minus sign here inside the bracket. So here minus, this is also minus. Which means now I will just write down my A and B. So obviously my A is positive 3 and my B is positive 5. Okay. Then now according to the formula just now, your R is square root of A squared plus B squared. That is going to be square root of 3 squared plus 5 squared. Okay, then you will be getting square root of 34. Alright, so then from here, I will know that my alpha at the same time, it will be arctangent b over a. So this is going to be arctangent. My b is 5, so my a is positive 3. That means now here, now you can check. Your alpha is between 0 and half pi. That means it is in the radians mode. Okay, so now I will write my answer as 1.0304. But then, since you need to express in this form, therefore I will round up. Okay, I give more significant here first because later I might use this value for the calculation. So for the next calculation, we will be using the value with more significant values, right? So then from here, as my final answer, I will just write my 3 sine theta minus 5 cos theta is going to be my r is square root 34, which is the exact value, or you can just simplify it. And then sine theta minus 1.03. So that is the solution for the first part, the harmonic form. Okay, after that, first part, hence means use this form, write down the greatest and least value for the function. Okay, so now A, 1 over 6 plus 3 sine theta minus 5 cos theta. Okay, so you should understand that these two terms, same as the previous answer, which is square root 34 sine. That means here I will change to 1 over 6 plus square root 34 sine theta minus 1.03. Okay, so then from here, to find the least and greatest value. So whenever you see value, that means it is referring to the whole value here, which is a y value. Okay, if I let this function be y, so I need to find out what are my greatest and least value for the y. Okay, and still the corresponding positive theta value. All right. So from here, I will say that now since my denominator, you see here, numerator is 1. Here is 6. These two are constants. But then this value, square root 34 sine theta minus 1.03 is not a fixed number. It's not constant. Right? We know that sine theta is between 1 and minus 1. Okay? So sine theta is between 1 and minus 1. By looking at the value here, you are not given the theta value, the theta interval. Okay, so now I will just consider in general. So therefore, sine theta minus 1.03. So this sine theta minus 1.03 is actually the translation of the graph, which means you are moving the sine theta to the right side for 1.03 units. So that means the y value remains the same, no change. It is still between minus 1 and 1. But then here we have square root 34. So I multiply it by square root 34. Therefore, my interval becomes square root 34 and negative square root 34. Okay, so now from here I know that my minimum value for this is going to be negative square root 1 over 34. This is my minimum value. But then my maximum value is going to be positive square root 34. Okay, just for this itself. So now, to solve the problem, the greatest value of 1 over 6 plus square root 34 sine theta minus 1.03. So you must understand that it is, now if you need to get greatest value for this rational function whereby the variable, the one that changing is called variable, okay? That means the sign, the term with the sign is the denominator. So we must use this concept. 1 over minimum is going to be maximum. Okay, 1 over maximum, it will be minimum. So now, greatest is actually the maximum. Therefore, I will be using this concept because we need to find greatest value. So I have to use this. It will be 1 over minimum. So now, this is going to be 1 over 6 plus. So my denominator must be the minimum value. Right? Since the 6 plus is a fixed number, is constant, then the minimum value, it will be the square root of sine theta minus 1.03. So by looking at the previous part, the minimum is negative square root 34. So I will write here negative square root 34. Okay? Then from here, you can just rationalize it. So this becomes 1 over 6 minus square root 34. So to rationalize it, right? So we are going to times the conjugate. So this is 6 plus square root 34 over 6 plus square root 34. Alright, so now then from here, you will just get 6 plus square root 34 over, so this is solved by a squared minus b squared is going to be a minus b times a plus b. Alright, so your a is 6, your b is square root 34. So when you use this formula, square 6 is 36. So 36 minus square of square root 34, that is going to be 2. Okay, so you can just leave your answer in this form. And now we need to write down the smallest positive theta as well. So which means now, okay, this happens when the sine theta minus 1.03 equals to minus 1. Right, based on here, this is minus 1. That's why you get the minus over here. So then, now, you are not given the interval. So now you have to solve this based on the sine graph. Okay, so I will sketch a sine graph over here. Our sine graph is this. Alright, so I will just refer to the sine, right? It's sine theta, it's not sine theta minus 1.03. This is a sine graph. Y equals to sine theta. Alright, so this is a theta. And now when it is minus 1, that means it is here. So if you refer to the question, right? Okay, so I will write down my theta in radians. So because I use radians because this 1.03 is radians, right? So when I do calculation, I will not write 1.03. I will use back the actual value, which is 1.0304. That will be more accurate. So later on, here I will just write 1.0304. Okay, sine of that equals to minus 1. So again, here when you refer to the sine graph, this is going to be 3 pi over 2. So now, okay, when it is 3 pi over 2, let's check here. It will be theta minus 1.0304 equals to 3 pi over 2. So when I need to find the theta, I'm going to move this negative value to the right side. That means it becomes more positive, right? So my theta is going to be 3 pi plus 2. 3 pi over 2 plus 1.0304. Then this is going to be 5.74 radians. Right? So then you have to check. I can also extend this graph to the negative part because later on we need to plus with this value. So it might be smaller. It might be the smallest positive theta. So here, obviously, this is negative pi over 2. Okay? So I have to calculate another one. So or theta minus 1.0304 equals to negative pi over 2. Then now my theta is minus half pi plus 1.0304. And then from here you will find out that it is negative value. Okay, so it means that this one will not be accepted. So omitted. Because we are looking for the smallest positive theta. Therefore, smallest positive theta equals to 5.74 radians. Okay, so you have to consider both because sometimes you might be getting the answer when you consider the negative angle. Alright, so this is the theta when we are finding the greatest value for the function. And now we need to proceed with the smallest or the least. The least value of 1 over 6 plus root 34 square root 34 sine. So square root 34 sine theta minus 1.03. Okay, so the least value is going to be 1 over maximum. Okay, which is here. 1 over maximum is minimum. So the maximum is square root 34 from the previous part. So I will replace the whole sign by square root 34. Positive. So this is 1 over 6 plus square root 34. Okay, and we do not leave our answer with the square root in the denominator. So what to do is, same as just now, you just rationalize it by multiplying the conjugate. Okay, then here is going to be 6 minus square root 34. And then when you expand, it is 2. And now, this happens when the sine theta minus 1.0304 is 1, positive 1. Okay, then now here, When it is positive 1, now check your graph. Okay, so when positive 1, I might get half pi, or this is going to be negative 3 over 2 pi. Alright, so I will consider half pi first. So theta minus 1.0304 is half pi. Okay, and then your theta is half pi plus that. Then you will be getting 2.60 radians. So if you consider the negative value, okay, because now you see here, the negative value is negative 3 over 2 pi. So this is more negative, okay, because half pi, the pi is 3.7. Wait, 3.142. So when 3.142 you divide by 2, that is only 1.57. So that value is more negative. Okay, so when more negative and you plus with this, it is still negative. That means here I will just consider one value. Therefore, my smallest positive theta is going to be 2.60 radians. Okay, for least value, from least value, yes, right? Okay, so done for the A. Now for the B, solve the equation. So you should understand, or you should realize that these two terms are same as the harmonic form. Okay, then I will just use the answer from the first part to solve it. So now B, it will be 3 sine minus 5 cos plus 2. So 3 sine minus 5 cos plus 2 equals to 0. And the interval is minus pi to pi. Okay, so the left hand side, the first two terms on the right, on the left side, I will just replace them by the harmonic form. So the harmonic form is square root 34 sine theta minus, instead of 1.03, then now here I will use the actual value 1.0304. It's not to say actual value, that is more accurate value. Okay, so 1.0304, then plus 2 equals to 0. Then from here, the 2 will be moved to the other side and the square root 34 will be moved down as well. So sine theta minus 1.0304 equals to negative 2 over square root 34. Okay, then you will be getting negative 0.34. Now here it's not recommended to give 3 significant figures because this is just the working, so I will give more. But then if I look at the fourth significant figure, that is 9, then the next one is also 9, then 7, so I give more here. Alright, so now your theta is between minus pi and pi. That means now here I need to find out what is my new interval for this angle. So I will minus 1.0304 from the whole inequality. Therefore, this is going to be negative 4.1720. It's like minus pi minus 1.0304 to get this negative 4.1720. So you get the new interval first. And the last term here should be pi minus 1.0304. That's going to be 2.1112. Okay, and now here, by looking at this value, the sign is negative. So I will just draw the quadrant. Alright, sine theta is negative 1.0304. So I'll draw the quadrant. Sine negative means it is in the third and fourth quadrant. Alright, and now I need to find out the basic angle. So the basic angle will be these two angles. It is at sine 0.342997. And this is in radians mode, so I will get 0.3501. So now I label both angles. Okay, then now my theta minus 1.0304 It's going to be, okay, now look at this interval. So your interval will be from negative 4.1720 until 2.1112. Okay, which means now here, my angle, I can accept negative value. So that is my first value. Okay, and then I cannot accept this, right? Because if I accept this, this is more than 1 pi. So remember, 1 pi is 3.14. And then here we only accept up to 2.1112. That means the orange, the bigger one cannot be accepted. But then we have to refer to the green color. So these are the two angles that we can get from the quadrant. So then the first one, since it is the angles are counted below the x-axis, right, or below the horizontal line. I would say below this horizontal line, both of them will be negative. So the first one is negative 0.3501, and then the next one is going to be negative pi minus 0.3501, because one line is pi. Okay, this is pi. But then since this is below, okay, or I will say that it is clockwise direction, then it's negative. So then you will be getting negative 0.3501, and the other value is going to be negative 2.7915. And now your theta, so move this negative value to the right side. So when you move it to the right side, it becomes plus. So I will be getting negative 0.3501 plus 1.0304, and the other one is negative 2.7915 plus 1.0304. So at last, you will be getting 0.6803 and negative 1.7611. Okay, so if you get this new interval, you will be getting the answer within this interval. Okay, because we at this stage we have considered the interval here. Otherwise, you might get the answer which is out of the range. So then, of course, the final answer must be three significant figures. So now we round up. So it will be 0.680 and negative 1.76. Okay, so that's all for this working. Now for question number 2, express 3 sine x plus 2 cos x minus 1 over 3 pi in the form r cos x minus alpha. Okay, this is the first form. And okay, where r is greater than 0 and alpha is between 0 and 90 degrees, giving alpha equal to 2 decimal places. Okay, so now hence solve the equation for x from 0 to 360 degrees. So firstly, rewrite the question. Okay, but then I will not write this first because I noticed that this is x minus pi over 3. So if you use the formula, it should be just x. Therefore, I have to simplify it first by using the addition formula in the previous video. So it will be cos A minus B. This is going to be cos A, cos B, plus sine A, sine B. Okay, so I will simplify it first. This is 3 sine x plus 2. So now my A is x, my B is pi over 3. Therefore, it is cos x cos pi over 3 plus sine x sine pi over 3. Okay, now we simplify first. So 3 sine x plus 2 cos pi over 3 is actually half. So half cos x. Then sine pi over 3 is root 3 over 2. Then from here, when you simplify the half and the 2, that is 3 sine x plus cos x plus root 3 sine x. Then at last, you will be getting 3 plus root 3 sine x, then plus cos x. Okay, so now here look at this. You need to express in r cos. So when r cos, the first term should be cos instead of sine. So which means now here I will write 3 sine x plus 2 cos x minus pi over 3. I have to rearrange. So, I rewrite the question first. Okay, so because of the right side is cos, so which means I have to write the cos x as the first term, plus 3 plus root 3 sine x, then equals to r cos x minus alpha. Okay, so which means now my a is 1 because it's 1 cos x, and then the b is going to be 3 plus root 3. Okay, done for the a and b. So therefore my r is going to be square root of a squared plus b squared. Then that is square root of 1 square plus 3 plus root 3 squared. And then you can just give your answer correct to, in decimal or in fraction up or in exact value, up to you. So here will be 4.83. I give more decimal places, 656. So before I round up I'll round up into 3 significant figures. So it will be 4.84. Okay. At the same time, my alpha value, use the same formula, arctangent b over a. Then this is going to be arctangent 3 plus root 3 over 1. And then this is, okay, let's check the question. Given alpha to 2 decimal places for degrees, okay, in terms of degrees. So that means now here, change your mode of the calculator to degrees. Even though it's mentioned 2 decimal places, but then I will write down this more decimal places first, then I will round up. Okay, so lastly, the answer, 3 sine x plus 2 cos x minus 1 over 3 pi is going to be 4.84. Then cos x minus 78.07 degrees. So this will be the solution of first part. Okay, next, hence solve. Right here, hence solve. So the left side will be exactly same as the harmonic form, then equals to 5. So I will just write 3 sine x plus 2 cos x minus pi over 3 equals to square root 5. Then the x is from 0 to 360 degrees, not inclusive. So which means the left side, it will be 4.84. Okay, I do not use 4. I will use this value. So it will be 38656. Then cos, rewrite this, x minus 78.0675 degrees equals to square root 5. Okay, so divide the whole equation by 4.85, 83656. So cos x minus 78.0675 degrees equals to square root 5 over the coefficient of the cos. And this is going to be 0.462326. So you can give more decimal places or more significant figures because this is the working. Now, after this, we are going to draw the quadrant. Okay, by looking at here, right? Or probably you can just write down the new interval first. Now, x minus 78.0675 degrees. So you have to minus this value from 0 and 360 degrees. So you will be getting negative 78.0675 degrees. And the other one is 360 degrees minus 78.0675 degrees. Then the upper limit is 281.93 degrees. Okay, so after you found this, then I will just write down my basic angle equals to arc cos 0.462326, and this is going to be 62.46 degrees. I give more decimal places. So now we look at the interval over here. Okay, so and then the cos is positive, which means now our theta will be in first and last quadrant. So I will label these two basic angles. I give more decimal places because here you have x minus the angle which is in more decimal places. So then I will just write my x minus 78.0675 degrees. So by looking at this interval, okay, I can accept this value as positive, and then negative 78.0675, that means I can accept this as well. Okay, one in positive, one in negative. You cannot accept this whole value because this green color is greater than 281.93. Therefore, we cannot accept the green color, but we have to accept both orange color. Okay, so what to do now here is the first value is positive and the second value is negative. So when you move the minus 78.0675 to the right side, it becomes plus. Therefore, I will get 62.46 plus 78.0675 degrees. That is going to be 140.55 degrees. And the other one is 15.61 degrees. And now, we must remember the the angle in degrees must be one decimal place. Okay, so here you round up. It will be 140.6 degrees and the other one is 15.6. So 15.6 degrees. Alright, so that's all for this working. Okay, so the third question, A. Express square root 3 plus cotangent theta in the form r cosec theta sine theta plus alpha, where r is greater than 0 and alpha in between 0 and half pi. B. Hence, show that square root 3 plus cotangent theta is between these two values. Okay, so I will rewrite the question first. Okay, we know that cosec is 1 over sine. So I will write r times 1 over sine theta. And then for the sine theta plus alpha, you must remember whenever you see r, right, you must either get r sine theta plus minus alpha or r cos theta plus minus alpha. So you should not have sine theta plus alpha. Okay, so here we have to do expansion. Again, now for this expansion, you need to refer to the addition formula or the compound angle formula, which is sine A plus B. So in this case, our A is theta, B is alpha. Then you will be getting sine A cos B plus cos A sine B. Okay, this is the addition formula or the compound angle formula. Alright, so by using this formula, you will be getting sine theta cos alpha plus cos theta sine alpha. And don't forget there is a sine theta in the denominator here. That means now I have to simplify. So the first one, when I simplify, I will be cancel off the sine theta. And then the second one, the sine theta will be moved into the second term. So I will be getting r cos alpha plus cos theta over sine theta times sine alpha. Okay, that means now here you will be getting r cos alpha plus r cotangent theta sine alpha. Okay, because the cos theta over sine theta is cotangent theta. And then from here, I can just check. This is square root 3 plus cotangent theta. Okay, so what to do here is, you see here, the cotangent theta is the second term. That means now when you do comparison, left and right side, square root 3 is basically r cos theta. Okay, and then the 1 here, the 1, okay, this is the 1, equals to the rest of the terms, r sine theta, or r sine alpha, sorry, r sine alpha. So from here, I will get square root 3 equals to r cos alpha as my first term, Then the 1 equals to r sine alpha. So I'm getting two equations right now. Okay, so what to do is I can just use 1 square. I square the first equation, so it will be 3 equals to r square cos squared alpha. And let this be third equation. And I square the second equation. That's going to be 1 equals to r square sine squared alpha. So now I will add up these two equations. So 3 plus 4, or the third plus the fourth equation. So you will be getting 3 plus 1 is 4. Then r square cos squared alpha plus r squared sine squared alpha. Then from here, factorize r squared. Then you will be getting cos squared alpha plus sine squared alpha times r equals to 4. So from the P1, okay, the AS, trigonometry, sine squared plus cos squared is basically 1. Therefore, I will just write r squared equals to 4. So my r supposedly plus minus square root 4, which is plus minus 2. But then it's given in the question your r is greater than 0. So then, since r is greater than 0, therefore your r is positive 2. So we have found the r here. And now, to get the theta, okay, so to get the theta, I will just use sine theta. To get the alpha, I will just use sine alpha over cos alpha, which means the second equation over first equation. Refer to these two original equations. So when I divide, it will be 1 over square root 3 on the left side. Right side, when you divide r, okay, I write down first r sine alpha over r cos alpha. So the r will be cancelled off. And then the sine alpha over cos alpha is basically tangent alpha. Okay, then now your alpha is arctangent 1 over square root 3. Okay, so let's check the question here first. Your alpha in radians. Right? So now change the mode of calculator into radians, and then your alpha is going to be pi over 6. Therefore, okay, now I get the form. You can just write root 3 plus cotangent theta. That is r cosec theta. So my r is 2. 2 cosec theta. And then sine theta plus alpha. Okay, so done for this question. Okay, now part B, hence, show. So we need to show the square root 3 plus cotangent theta is in between that. So I will write down my square root 3. So square root 3 plus cotangent theta is 2 cosec. Okay, so from here, look at the question over here. We need to show that it is in between minus 2 cosec theta and positive 2 cosec theta. So what to do here is, I will just consider the sign. So we know that sine theta plus pi over 6 is always between minus 1 and 1. Okay, this will be the maximum and minimum values for sine theta. So the plus pi over 6 is just a translation. You are moving the graph to the left side, the sine graph to the left side for pi over 6 units. So from here, I know that, alright, if I get this as the subject, which means I need to move the 2 cosec theta to the left side. So I will be getting square root 3 plus cot theta over 2 cosec theta. So it will be between minus 1 and 1 because I'm just replacing the expression for sine theta plus pi over 6. So from here, okay, I will just move this 2 cosec theta, or I can just times it to the whole inequality. So which means now I will be getting root 3 plus cotangent theta is between negative 2 cosec theta and positive 2 cosec theta. So with this, I have shown the inequality. Alright, so done for this question. Okay, so that's all for this video. Thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my videos. And stay tuned for more upcoming videos. Thank you everyone. Bye.